Hello, this is Mr. Standerson, and in this example, I want to run through a couple example problems that tie a few big ideas together that we've been learning about with frequency, wavelength, and also wave speed. And then in addition to, we're going to go over how to solve this if there was an echo. So we're going to talk about a few of those examples in this short mini lesson. Let me explain one of the problem situations that you might encounter. For example, let's say you have a wind chime and it's next to an office building. We know the frequency of the wind chime is 440 hertz, so I can fill that in down here. We know that the frequency is 440 hertz. And we also know that the wind chime is played next to an office building, and then there's an echo that's heard. Now, an echo, of course, is something that travels, bounces off the surface, and then travels back. We know the time for that round trip, so the down and the back, is 3 seconds. Okay, so that's going to come into play. And then the problem's asking us, how far away is the office building if the wavelength of the sound through the air is 0.773 meters? Okay, so I wrote that down already for the wavelength. What they're asking about, though, is from the chime to the building, what is that distance? Okay, so I want us to think back to some equations that we know. For example, we know that we can calculate distance if the velocity is constant, right? And the velocity of sound through a medium is constant. In here it says that the sound wave is traveling through air. So the medium doesn't change, therefore the speed of sound is not going to change from once it's sounded at the chime to when it hits the office building and when it bounces back. When there's a constant velocity, I know that my distance can be calculated if I know that velocity times the amount of time it takes to travel. In this case, the speed that we're talking about is going to be the speed of sound in air. And the time we're going to be talking about is the time for the one of the paths, right? Either from the chimes to the building or from the building to the chimes. Otherwise, we would be calculating there and back. This would be twice the distance. And all we really want to know is how far it is between the two objects. Okay, so I can't use 3 seconds for my time because that's the total round trip time. But I can use half of that. So the time that I'm going to want to use for this case is equal to 1.5 seconds. Now, if that's not clear, please reach out and let me know. But take a look at that idea of an echo. It's always going there and bouncing back. So for this situation, we're going to use half the time for you to actually hear the echo because we're just wanting to know the distance between the two objects. Now, the next thing we want to do is calculate the velocity. And this velocity is the velocity of the sound wave. All right, so I know in order to find velocity of sound, or any wave for that matter, I can take the frequency of the wave times the wavelength. And sure enough, I have both those quantities in this problem. So I'm going to substitute in 440 hertz for my frequency times the wavelength of 0.773 meters. Then I'm going to do a little calculation. At this point, I'm going to get a velocity of around 340.12 meters per second. All right. Now I'm going to take that answer and plug it in for the velocity here. I'm going to take this time and plug it in for the time here, and we'll be able to calculate how far apart these two objects are. All right, so let's do that over here. So the distance is equal then to 340.12 meters per second times 1.5 seconds. I'm going to do that on my calculator quick. And I get about 510.18 meters. So according to the information they've given us, the distance here between the two objects would be about 510.18 meters. Okay, hopefully that makes sense. We combined a couple big ideas with how to find wave speed, knowing your frequency and your wavelength, and then thinking about an echo as being a down and back, using half the time in the problem to help us find out the total distance. Please reach out if you have any questions. Thanks and have a great day.